and welcome to the Talking Crop podcast. My name is Catherine Seabrook, and I'm a commercial agriculture educator with University of Illinois Extension serving Daviess, Stevenson, and Winnebago counties. Talking Crop is a row crop production podcast with episodes occurring every other week during the growing season between May and September. In each episode, I bring on a guest speaker to discuss topics related to their areas of expertise. In today's episode, I talk with Dr. John Jones, an Extension Soil Fertility Specialist with the University of Illinois Department of Crop Sciences. Dr. Jones discusses the work he's done and will continue to do to update corn nitrogen recommendations, in addition to how we can better understand the soil supplying power of nitrogen, as well as work being done to update phosphorus and potassium recommendations. As always, check out the episode description to find my contact information and a link to a survey that you can complete about Talking Crop to offer up any suggestions or comments. For today's episode, you will also find Dr. Jones's contact information as well as links to the Corn Nitrogen Rate Calculator website and the webinar that Dr. Jones did this spring with the Illinois Fertilizer and Chemical Association that expands on what we talk about in this episode. On the next episode of Talking Crop, I'll be speaking with Dr. Harkirat Kaur, Assistant Professor and Extension Specialist with the University of Wisconsin-Madison Department of Plant and Agroecosystem Sciences, about sustainable corn production systems and abiotic stress in corn. That episode will air on Wednesday, June 25th. And now, onto this episode of Talking Crop, Refining Corn Nitrogen Recommendations with Dr. John Jones. Dr. Jones, thank you for joining me today for the Talking Crop podcast. I'm really excited to talk about a few really important topics that I think a lot of people are going to be interested in. So again, just thank you for joining me, especially since you're out on the road right now.
Thanks, Catherine. I appreciate it. I'm excited to have a conversation today. Yep, we're not too far from Nashville, Illinois right now. We're doing a grid soil sampling project. So out in the field, beautiful day, trying to beat the rain.
I just want to start out talking about updates to corn nitrogen recommendations that you've been involved in. So can you just kind of briefly talk about maybe the history of that first, like why these recommendations are needing updates and what has gone into that?
Sure. The updates or refinement, kind of annual changes to the recommendations or guidelines that the University of Illinois publishes through the Corn Nitrogen Rate Calculator website are really to reflect interpreting recent nitrogen rate trials on farms across Illinois. And so in general, the past, I'll say 2 decades, really almost 3 decades, there's been a strong program of on-farm and on-research station nitrogen rate trials looking at corn yield response to nitrogen. Those are led by Dr. Emerson Nafziger and Dan Schaefer with Illinois Fertilizer and Chemical Association. And essentially, the interpretation is broken out into central, northern, and southern parts of Illinois. We look at previous crop, and then there's a consideration for pricing scenarios or conditions. And that philosophy of interpreting yield response to nitrogen is, again, really came about in the early 2000s and has been in place in many Corn Belt states. And there's been some refinement in different states and philosophies of how that's done. The work that I'm doing now is kind of get into my first spring season within Illinois is looking at really making sure that we have a solid representation of the varying soils and cropping systems in Illinois when we're looking at interpreting yield response to nitrogen for corn. And it's very evident when you look in previous data sets or interpretations that the more representative we can make the data sets and the analysis, the more accurate those recommendations are. This system and philosophy is really designed to work where it was similar soils that the research was done in, similar soils and cropping systems. And so it's really kind of exciting because it means that we get to get out around the state and work on implementing trials, working with farmers or agronomists around the state. And so that's really where some of the updates or refinements come from. The recent changes in 2025 are also a result of not considering any older data that is past 10 years after the current growing season. So that's about the cutoff that we ended up putting on the data set that's currently interpreted on the corn N rate calculator website. And there are a few reasons to do that. One, simple management systems and cropping systems that change with specific hybrids and growing conditions. Yield levels are certainly things that when we look at the yield at the optimum nitrogen rate for a given trial, for parts of the state, or for the state as a whole, it has gone up over time. And it's really clear and evident, we know from research, that when we quantify total nitrogen uptake of a corn plant, higher yields demand more nitrogen in that plant. And there's maybe some challenges. It's not always a concentration, but on an acre basis, we're seeing increases in total nitrogen uptake as our yields increase. And so our general hybrids have improved in, we'll say, nitrogen use efficiency, depending on how you define that. There's a few different ways. But in general, because we're increasing our yields on an area basis per acre, we're increasing our total nitrogen uptake as well. Now, that kind of gets into the point of, well, do higher yields require more nitrogen? They were on an acre basis. Yes, it does require more nitrogen, but it doesn't necessarily always equate to fertilizer nitrogen, because we know a significant portion of the nitrogen that a corn plant sources is from the soil. And so the big challenge is we're increasing our yields. Our systems are cycling nutrients faster than we've ever asked them to do before, right? Or running our soils essentially at a higher RPM. And the question is, can the soil then keep up with that demand for nitrogen? And then how specifically does the fertilizer surplus of nitrogen that needs to be applied, or supplement of nitrogen that needs to be applied to meet the total end demand, where does it fit regionally, on a field farm level, field level, and subfield level? And so that's what we're really trying to look at. The changes to the numbers in 2025, again, reflect really dropping some older data that I think made sense for our cropping systems and where we're at for our yield levels. And as if you look at some of the information that we've put out on some webinars in the past as well, you'd see that there's been an increase in optimum N rates than in most regions of the state. And mostly those changes are in corn following soybean, where in north central and southern Illinois, we saw an increase in optimum N rates when disregarding that older data. For corn following corn, we really didn't see a large change. Now, there's a caveat to that our data does have more sites of corn following soybean than corn following corn, but it generally reflects, I'll say, the ratio of acres of continuous corn versus corn after soybeans. One other big change that we did make, and really it's reflected of having good data, because good data leads to more accurate insights, is we did drop any interpretation for continuous corn in southern Illinois, just because of the lack of that system maybe being as present. I wasn't comfortable with the amount of data that we just didn't have for interpreting that as well. So those are kind of some of the big changes. Again, you'll see increases in optimum N rates, but I think that's been observed in many other states around the Corn Belt as well.
So you talked about how the biggest change has been dropping that old data. It's not indicative of what's happening currently. So going forward, are there plans to continue these trials to make sure that the data is consistently up to date so that you don't have to go through this whole kind of rigorous process again?
Yes, that's the short answer, is yes. So we're really ramping up. Specifically, historically, there's been a very good representation in central Illinois of on-farm N rate trials, mostly because of the collaborators that have been involved. So what I'm really focusing on is increasing those numbers in the northern part of the state. But then also we've got a really strong collaborator with John Pike in the southern part of the state that we're also kind of building some numbers up as well. So the idea is that eventually we'll be running probably 50 to 75 trials a year on farm around the state. And those are comprehensive, full 6 nitrogen rates, replicated trials. Sometimes they're designed a little bit differently. Sometimes they're traditional strips. Sometimes we're going a little more advanced and looking at kind of a patchwork design across the whole field. So we're taking more spatial differences in response into consideration. Really, we can design them to whatever comfort level the farmer or agronomist is wanting to put those in. So we're actually going to ramping up some of those numbers around the state, and we're doing that this year. Just an example, Last fall, I was coming onto campus. I wanted to add 10 more sites in the northern part of the state. And I think at least in the additional trials that we ended up with, I think we have 38 more. And so there's certainly a really great demand for wanting to collaborate on these trials. And what we're doing is also collecting some more metadata from them. So we're looking at soil nitrogen availability. If the logistics of the trial work out, we're looking at total nitrogen uptake at different parts of the season. So really, we want to quantify some other metrics of N supply from the soil and corn nitrogen demand, and try to layer that on top of the yield response to nitrogen as well. So very much in I'll say a ramping up and refining of the process. We're also making sure that we're continuously looking at the other R's besides rate. So we're doing timing trials, source trials, but wanting to make sure that that represents the nitrogen management systems that are regional around the state. So focusing on really still considering the dynamics of fall applied anhydrous ammonia in the central and northern part of Illinois, looking at how the interaction of anhydrous in the spring affects N availability in the southern part of the state as well, or central and southern part of the state. So we really want to make sure that those systems capture, again, the locations that the data can be used and interpreted.
And so nitrogen management as a whole is obviously and understandably a really big and important topic for producers. They have to take into account pricing, soil supplying power, nutrient loss. There's a lot of different things that they have to balance to quote unquote get it right. And like you mentioned previously, you talked about how that increase in yield that we've seen over the past, number of years has equated to more nitrogen uptake. But that doesn't always necessarily mean more fertilizer nitrogen uptake. So really it comes down to getting a better understanding of the soil supplying power of nitrogen. And that is a question that a lot of producers talk about. Is there specific work going into getting a better understanding of that?
Yeah, so it's kind of interesting. There's always cycles in research and application of what questions farmers, agronomists, and scientists have. Tools to look at available nitrogen really have to probably either do one of two things. Either they're going to be identifying a snapshot of inorganic nitrogen that's available. So you can think of our soil nitrate and ammonium tests. Maybe that's referred to as a pre-plant nitrate test, pre-side dress nitrate test, or late spring nitrate test, depending on what state you're in. It has a different acronym. But so those are kind of capturing a snapshot of available inorganic nitrogen that if a plant root is right next to that element, it's going to be available to those plants. And certainly the ammonium specifically could get converted over to nitrate. Then there's also tests that are trying to estimate a mineralization or transformation of organic nitrogen within the soil, in the soil organic matter complex, to an inorganic form that you're measuring in the snapshot. So it's more of a prediction or a surrogate for what can the soil supply. Overwhelmingly, there's been some challenges and to interpreting these. There was a lot of research done in the late 1980s, early 90s, into the 2000s on pre-side dress nitrate tests or late spring nitrate tests. And I think the challenging part was always if you were in an area where there was high residual nitrate, like in Western states, there was a lot of kind of logical steps. There was a lot of nitrate that would be carried over. In most of Illinois, we maybe don't have quite that carryover that you'd see in western areas, a little more arid. And we don't probably have in all parts of the state, we don't have the presence of, we'll say, historical manure applications, alfalfa in rotations that you would have seen, again, decades ago, which certainly affect the amount of inorganic N that's available. And so interpreting a nitrate or ammonium value becomes a little bit challenging because it is just a snapshot. It's really looking at the majority of nitrate or ammonium that's in the soil solution, or that's fairly loosely connected or attracted to the soil exchange sites. All right, so similar to a little bit, let's say, a weaker soil test than compared to like a phosphorus or potassium test that's using stronger acids to look at not just nutrients in solution, but that are potentially available down the road as well. And so the what's usually done for the nitrate and ammonium test is you run a a yield response to nitrogen trial. You find an optimum nitrogen rate, and then you relate that to the soil nitrogen amount that was in your control. We'll assume anything you didn't apply fertilizer to, the soil supported the yield of that corn crop, and you do that across tens or dozens, maybe even hundreds of sites, and you come up with a relationship between nitrogen in the soil and essentially nitrogen response to fertilization. And then it's really the similar process that we do when we look at soil test phosphorus and potassium interpretations. The challenge with nitrate and ammonium is that, and concentration and trying to interpret them, is that they do change fairly rapidly and they change fairly quickly across space. Again, we're right out in the field right now where we're grid sampling pre-side dress nitrate tests and looking at other soil properties as well. And I can tell you, as we're developing these maps of soil nitrate in the upper 12 inches of the soil, we see some really large variability that sometimes it's hard to predict. And that's what we want to do. We want to predict, hopefully, a system where that you don't have to go out and take this many samples at this time of the year when everyone is very busy. And largely, that's probably why these types of tests really haven't been very popular, is because field work days are at a premium. And this is a tough time of the year to say, all right, go grid sample at 1 acre, 2.5 acres, or 5 acre grids. And so this is a challenging process. So what we're trying to do with this data is also see if we can start predicting it as well. So that's kind of, a long-winded answer to your nitrogen availability tests within the soil. The other surrogates for nitrogen mineralization usually depend on trying to represent some type of biological activity surrogate within the soil, whether that's carbon dioxide respiration. That's a fairly more popular test that's kind of has a soil health focus. There's different, I'll say, transformations of organic to inorganic nitrogen, depending on the lab method you use. And that value then is used to estimate potentially mineralized nitrogen. There's incubations you can do for 7 days. And essentially you say, well, I'm going to flush the nitrate out of the soil. Whatever nitrate mineralizes within 7 days, that's what the soil potential is. So there are those tests as well. And it's the biggest challenge is we just haven't found really clear-cut relationships with optimum nitrogen rate. And I think there's a temporal aspect and a spatial aspect that we really just don't always catch as well. I'll add one thing that we're also working on in our group is looking at what timings of nitrogen application and times of corn growth stage is that corn not necessarily favoring, but relying on soil versus fertilizer nitrogen. We got a project that'll be starting this fall to look at that a little more in depth so we can say, in this part of the growing season, when nitrogen was applied at this time, the corn was really getting most of its nitrogen from the soil. But at maybe this time of the year, it was getting a little more from fertilizer. So we've got some ongoing research to look at that as well.
So when it comes to kind of the work that you're doing and the work that the nutrient loss reduction strategy team is doing, is there any way to know, is the nutrient loss for nitrogen that's ending up in groundwater, is that coming from a fertilizer source or just the soil source? Is there a way to figure that out?
There are some ways of making proxy or surrogate measurements for that you can suggest that there's probably a dominant source of nitrogen that's being lost. It's not always a clear-cut relationship. We don't have any projects in our group doing that right now, but I know I think Dr. Zhangji Yu in Natural Resource and Environmental Science Department at U of I is working on some of that research related to tile drainage, nitrate losses or nitrate loading, and appropriating those losses to either fertilizer or soil. Essentially, the idea is that we should be able, through some either looking at isotopes, so different nitrogen atoms with varying atomic characteristics, that you can be able to identify soil versus fertilizer nitrogen that's being lost in the drainage water. I think usually what those efforts have found in many cases are that there's a significant amount of the nitrogen lost is sourced from the soil. And that's because of a few different factors. One, we do have a really large mineralization potential in most of our soils in Illinois because of the amount of organic matter, soil organic carbon and nitrogen. If they're in an area where we have tile drained, we've created an environment that usually does, facilitate movement of that mineralized nitrogen, but it also really leads to the ability for us to grow impressively large amounts of biomass and grain that we can make profitable systems off of those acres. And so there's kind of a challenge with saying, well, it's either soil or fertilizer, because of the second point is that, and I've seen this in my personal research in phosphorus, is that when we add nutrients to a system that is going to respond to those nutrients, it stimulates a mineralization of additional organic nutrients. So we can think about, we've seen this in low soil test phosphorus fields in previous states that I've worked in, where we've added phosphorus, but then we actually saw an increase in phosphorus mineralization. And so the inorganic fertilizer that was added spurred specific enzymes and microbial activity to release more organic phosphorus into the available pool. I suspect with nitrogen, you're seeing that as well. There's some older research, I shouldn't say that older, it's about 20 to 25 years old in Illinois, that looked at soil versus fertilizer supplied nitrogen at just a few different nitrogen rates, and showed that as you increase your nitrogen rate, you're actually getting more soil supplied nitrogen. Now, it's not making up for the fertilizer that's applied, but what it's probably doing is leading to some stimulation of microbial activity in the soil when we do apply those inorganic fertilizers. And so it's really hard, to your original question, to say, is it fertilizer or soil supplied end that we're losing? And I would say at the end of the day, it certainly is important to think about resource use efficiency, right? We're using our inputs in an efficient way. There's also data that's shown that we can store nitrogen back into the organic fraction that's even applied as fertilizer. And so the challenge of saying, well, it's specifically sourced from here or there, at the end, maybe we just have to think about, total nitrogen loss from the system and what we observe. The really encouraging results from research recently led by Lowell Gentry at the University of Illinois is showing that looking at different crop rotations and adding cover crops at the right time can reduce some of our nitrate losses to get to kind of goals of overall reductions of nitrate load. And it doesn't always have to be adding cover crops before corn is planted. It can be even just adding them before soybeans are planted in the rotation. And so I think one of the things that I hope that we keep communicating is that our systems are inherently leaky when we're trying to manage nutrients in general, not just nitrogen. We do lose potassium through tile drains, and it leaches out, and calcium and magnesium. Right? We just don't care about those as much because there's no water quality implications. But inherently, we are managing these systems so that there are going to be exports. There are going to be exports in the grain that we take to the elevator, and any nutrients that we lose to the environment as well. The idea is I would say that what we can do is try to work on making sure that these soils function in a way. And I think if you improve function, it does support reducing losses, but then also really maintaining, if not elevating, crop yields as well.
Sure. Yeah. And the reason I ask that is because I think the work that you're doing is really great because it should help folks understand, the quote unquote best rate to apply, right? So, because everyone wants to make sure that they're being efficient, not only for the fact that it helps the environment, but for the fact that it helps the producer's bottom line, right? So I was really wondering, with what you're doing, you talked about how we can kind of roughly estimate how much of the nitrogen is being supplied by the soil. And if we also have, like you said, there's teams measuring nitrogen loss through, tile drainage, is there a way to kind of look at those and combine those and get a better overall picture to help kind of both sides understand, what is the crop taking up, what is it not taking up, and how does that relate to, how can we calibrate what we're applying, so to speak?
Again, one of the The effects that we're seeing in research, and I've seen this in phosphorus research, and I think it mirrors what others have seen in nitrogen, is that when we start to manage nutrients kind of in an agronomic optimum mindset or an agronomic optimum target or category, we generally have minimized losses to the degree that there's not a whole lot of difference between not applying a nutrient and managing it at the agronomic optimum. It's not always the case, but an example in some of the research I did in graduate school for my PhD at Iowa State, we looked at phosphorus losses in tile drainage related to soil test phosphorus levels and phosphorus application levels. And generally, when we were maintaining our maintenance range or our optimum range of soil test phosphorus, we saw no difference between the low or not applying any phosphorus at all. So we can kind of think of this agronomic optimum management. It usually has environmental benefits because we've at least tried to, for that specific system, we've optimized the use of that input or that soil test phosphorus that's there already. So that's really encouraging, and we've seen this in looking at residual soil nitrogen after a corn or wheat crop, that the residual soil nitrogen in the upper 3 foot of the soil really doesn't change a whole lot from a zero control check up to where the economic optimum N rate is. It's when we start getting 30 to 40 to 50 pounds higher than the economic optimum N rate for corn and wheat that we see that kind of exponential increase in the amount of nitrate that's left over after the season.
So you mentioned a couple times in answering that previous question, phosphorus and potassium. So shifting gears into that area, are there any updates regarding soil test phosphorus and potassium recommendations? I know that it's both you and Dr. Andrew Margonaut are working on within this sphere. So from your side of things, can you talk about any updates in that area?
Sure. So I think the largest update is that we've got a lot of ongoing research on this topic, and I think I'm really excited in the collaboration between our two groups that we're going to be kind of attacking updates to guidelines, so like in the agronomy handbook and interpretations of soil test P and K, but then just general understanding of phosphorus and potassium cycling in our cropping systems. And so essentially when we think about updating guidelines or how we interpret soil tests for phosphorus and potassium, we need a few different steps. It generally gets categorized into 2 or 3. We have to essentially find soil test level that fertilizer either doesn't or does lead to a yield response or a higher yield. And that's usually called the critical soil test concentration. And usually it's a range of values. Then we have to say, well, okay, above and below that range, what rate should we apply? And so we go from correlation in the field to then field calibration, which is where we're identifying optimum rates for a given soil test range. And so that's going on right now as well. And we're doing it in the context of applying phosphorus and potassium at different times, different tillage systems, and different sources as well. So we can kind of think about that related to interpreting your soil test, but then also looking at an optimum rate that's specific for your type of system of management. Maybe it's no-till and strip-till, or we have tillage comparisons that we're looking at corn and soybean are in rotation, so that we can look at different P and K timings, whether it's a biennial or an annual application of nutrients. So those are kind of the research efforts that are going on now. We're also kind of looking at different fractions and forms of phosphorus and potassium within our soils, and then looking at that demand as well. The kind of early results are starting to come up, and we're starting to see some critical concentrations or levels, which would be generally related to the lower bound of the maintenance range. If you think about the agronomy handbook chapter 9, that we have maintenance ranges where we kind of flip from wanting to build soil test levels to wanting to at least apply crop removal. And in general, I wouldn't be surprised to see those shift a little bit. We've seen that pretty consistently across other Corn Belt states, and work that I've personally been involved in or led. And so right now we're starting to get quite a bit of data in to start interpreting those, and we'll be sharing results as probably this fall when we have really probably a nice slug of site years of data. One of the other things that we're looking at are how do soils respond to fertilization or crop removal. So this is something that's really in the background of any soil test interpretation recommendation is the amount of fertilizer it's needed to increase the soil test 1 pound per acre, or the amount of crop removal to reduce it 1 pound per acre. Overwhelmingly, that's assumed to be the same rate. So it takes the same amount of fertilizer or crop removal to affect the soil test level change. In my work, when I've looked at the kinetics of building up and drawing down soil test levels, I don't see them as equivalent. We're seeing some differences, and it kind of matches, honestly, what you hear if you're talking to farmers and agronomists. It's harder to draw down phosphorus levels, and it's harder to build up soil test potassium levels. And we're actually seeing that in some of the kind of the detailed like nutrient kinetics of how much nutrient or fertilizer it takes to increase or how much removal it takes to draw down. And I think what really that's reflecting is when we apply fertilizer and it starts to react with the soil, it moves to specific pools of phosphorus and potassium that it's going to essentially sit at or live in for a little while, and then maybe transform over time. We know phosphorus can get occluded by calcium over time. Potassium can move in and out of the interlayers between soil clays. But then that's probably not the same form that our plants are always accessing and removing. And so we've kind of got these underlying basic research challenges within the recommendation sphere of really applied research. So it's really exciting time to work on this all, because I think what we'll do is kind of challenge assumptions that we've had for how our soils respond to fertilizer removal. And it's important because if we really want to provide the highest ROI to fertilization, regardless of where your soil test level is, whether you're building up, you've maybe rented or bought a new piece of land that hadn't been soil tested for a while and you're needing to build soil test levels, or you're dealing with a soil that's relatively high testing and you want to make sure that you don't need to build up anymore and you can draw that down slowly. Can we predict how accurately how that soil test is going to draw down? They're not always clean relationships. Soil testing it certainly has its variability. I always say there's a quote: "You'll never step in the same river twice, but you can stub your toe on the same rock." And that's kind of similar to soil testing, is that you're probably never sampling the same soil twice, but you're trying to, over time, as you build data layers and track a given field or farm, then you can start to look at kind of directionality of where soil tests are headed. Because in the end of the day, they really are indices of availability. 42 pounds of P per acre in your soil test doesn't necessarily mean 42 pounds of available P that the crop is going to see a whole growing season. We're trying to use it as an index.
Yeah, these biological systems are very finicky. I know with what your groups are doing, it's just really important because of that finickiness. Although it's hard to narrow things down exactly, the work that you're doing is really, really great to help producers answer these questions as best as they can, to give them the best recommendations possible, so that, like I said before, at the end of the day, they're doing the best they can for their crops and helping their bottom line. So all of that to say, I think all of these recommendations, these updates, I should say, between the nitrogen, the phosphorus, and potassium, I think they're all going to be very well received by producers, and it's going to lead to some pretty exciting times, I think, in the near future when you guys are coming up on the ending of these trials and these results. So, Dr. Jones, thank you again so much for joining me today. I really appreciate your time, and hopefully we'll talk soon.
Great. Thanks, Catherine. I enjoyed it very much.